Hey guys, Mr. Betts here. We have a little bit more of a complicated example with infinite series. And in this series, essentially what we're doing is we're trying to take an infinite sum that's given to us and we're trying to find that sum. So remember, we use the limit of the partial sums to find the infinite sum. So we're looking for the actual value of the sum if we were to add infinitely many terms together. So to do that, we're going to look for a pattern here. We don't really know how to do this algebraically, and there's actually really no general way to do this algebraically. But this particular sum, we're going to see a pattern that we're going to be able to use. So what I'm going to do is I'm going to start writing out some terms here and see if we can recognize this pattern. So the first term is going to be, we plug 1 in, we get 1/2 minus 1. I'm going to put that in parentheses. I'm going to group the terms in parentheses here just for organizing purposes. Then the second term is when k equals 2. So that's going to be 1/3 minus 1/2. And when k equals 3, we're going to get 1/4 minus 1/3. And let's do one more here. So when k equals let's see, we're on 4 now. We're going to have 1/5 minus 1/4. And I'm going to put a ... there to show this does keep going forever. So our sum is going to be equal to this. What I'm concerned about here to start with, since we need it to actually find the actual sum, is I'm looking for the partial sums. So I'm going to do these one at a time here. The first partial sum is going to be just what we get when I add what I have in blue here. So 1/2 minus 1, and I'm actually just going to leave it as 1/2 minus 1. You'll see why in a little bit. The second partial sum, what's going to happen is the 1/2 here and the 1/2 here are going to cancel each other out. So the second partial sum is going to be 1/3 minus 1. You might start seeing a pattern here already. So the third partial sum, the 1/3s are going to cancel each other out, and what we have left is 1/4 minus 1. And the last one that we did here, s sub 4, the plus 1/4 and the minus 1/4 are going to cancel each other out, and that's going to leave us 1/5 minus 1. So I think hopefully you can see a pattern here. So the pattern is we're always going to have the minus 1, and then for the first partial sum, we're adding on the 1/2. Second partial sum, we're adding 1/3. So if we want the nth partial sum, or I'm sorry, in this case, we're going to use k, the kth partial sum, it's going to be something minus 1, and it's 1 over something. I do want to point out, though, that the denominator here is always 1 bigger than the k. So it's going to be 1 over k plus 1 minus 1. So going down to the limit then, to evaluate that limit, this is going to be the limit as k approaches infinity of 1 over k plus 1 minus 1. And as k gets really big, this 1 over k plus 1 is going to get really small. That's going to approach 0. And so our infinite sum is going to be -1. Okay, so remember, this is finding the sum of the infinite series by looking at the limit of the partial sums of that series.